Okay, welcome to the video for 4.3. I'm actually going to divide this up into two parts. So the objectives for our first part, we have four of them. Students will be able to graph radian and degree angles in standard position. Students will be able to find reference angles for radian and degree angles in standard position. Students will be able to identify positive and negative angles that are coterminal with given angles, and students will be able to find the exact value of 6 trigonometric ratios of an angle in standard position. Right now, this probably doesn't make a whole lot of sense to you, it's just a bunch of words, but you'll see that I've broken it out by the objectives down here, so you can see what you're trying to accomplish, what you're trying to master with each of these here. All right, so 4.3 is all about how do we find the trig ratio of an angle that is larger than 90 degrees or a negative angle. So far we've worked with all positive acute angles. So what happens when we have an angle that's bigger than 90 degrees? So in this first part one, we're just going to be focusing on the pieces that are going to get us to figuring this out. We're not actually going to answer this question until we get to part two, but that's where we're going with all of this. All right, so let's begin. So we're going to cover 4.3 Objective 1 and 4.3 Objective 2, graph an angle in standard position and find the reference angle, all right here. Okay, so what is an angle in standard position? This is an angle where the vertex is at the origin and the initial side lies along the positive x-axis. Let me show you what that looks like here. So we have our vertex at the origin, rather than just hanging out here someplace, and our initial side lies along the positive x-axis. So this is the initial side. And positive angles, let's just draw the terminal side out here. Positive angles are measured counterclockwise. So if we're measuring this for a positive angle, we would measure it this way. So this is positive. If we were measuring it for the negative angle, we would be going clockwise. Okay, reference angles are the acute positive angle measured to the x-axis. So let me get one more thing in here before we talk about that. If this is the initial side, this is the terminal side. And that's going to come up later on. Okay, I'm not going to label the vertex. Hopefully you know what that is, but it's getting kind of crowded here. So the reference angle then is the acute positive angle measured to the x-axis. So let's pick another color here. This angle right here is the reference angle. And we're going to practice finding that, but it's always to the x-axis. So example 1 here, graph the following angles in standard position and draw in the reference angle and label it theta. We're also going to find out what that measurement is. All right, so 13 pi over 4. So you could just change this to degrees, but it's really helpful if you can get used to counting by fractional parts. And it sounds hard and we're scared of fractions, but really once you get the hang of it, it's pretty easy and it's going to come in handy a lot in this unit. So far we know that this is 0 and we know that this is pi, and we can use that to help us count. So I'm going to show this to you one time, and I would suggest you even go back and watch it again to make sure you understand. So what I'm going to do here is I'm going to take this pi and make it so as a denominator 4, because that's what I need. That's the denominator I need for this problem. So I'm going to make it 4. But to keep this still pi, I need to make this 4 pi over 4. All right, so if this is 0 and this is 4 pi over 4, well, halfway around, I'm going to divide the top by 2, and I get 2 pi over 4. Okay, these are the steps. I didn't write it out, but if you want to write steps, go ahead and do that. But you're going to find this fraction, then figure out what half of that is, and now that you've figured that out, you can count each quadrant is worth 2 pi over 4. All right, so this is, now I can just count by 2's. 2 pi over 4, 4 pi. That means that this must be 6 pi. 6 pi over 4, and then if I count by 2's again, now I have 8 pi over 4. Well, that should make sense because this is the same as 2 pi. All the way around is 2 pi. Okay, so we're counting by twos. So we have 2, 4, 6, 8, 10. Actually, let me draw this in. We have, as we go around, 2, 4, 6, 8, 10, 12. Well, 13 pi then is going to be between 12, and if I count by twos, 14. So here's 13 pi over 4. Okay, so we've graphed the angle. Here's the initial side. Here is the terminal side. And now let's find the reference angle. So the reference angle, well, we're just going to look where the closest x-axis is from the terminal side, right? So not this way and not to the y-axis, but right here would be the reference angle. So our reference angle, what would that measurement be then? Right, so we were going around and we went 2 pi, 4, 6, 8, 10, 12, 13. So from 12 to 13 is just 1 pi. So 1 pi over 4. There we go. We've both graphed the angle and we found the reference angle. We're going to do that over here for this one. I started out with the harder one first. Feel free to pause this and try to figure this out, but negative just means we're going to go this way. And now we're working with degrees, so you're probably a little bit more familiar with that. We have, if I'm going in the negative direction, I have 0, negative 90, negative 180 degrees, negative 270. So as I go around, it's going to be somewhere in this quadrant right here, the second quadrant. So around like this. There we go. There is our negative 210. And now for the reference angle, well, it's the one that's closest x-axis. So right here would be our theta. And what is that measurement? So theta reference, the measurement is, well, from 180 to 210, if I subtract those, I'm going to come up with 30 degrees. And remember, this is a positive acute angle. I did come up with a positive acute angle here. So you can change this into degrees, but then you have to change it back because I'm going to want the answers, if they're in radians, I'm going to want them in radians. And moving along, there's going to be so much other stuff that you have to do that having that extra step in there is just going to make it harder. So I would practice counting by your fractional parts here. All right. So now for objective 4.3, number 3, identify positive and negative coterminal angles. So what is a coterminal angle? These are angles with the same initial side and the same terminal side, but they have different measures. So let me show you what I mean by that. All right, find and draw one positive and one negative angle that is coterminal with the given angle. So first we need to graph our original angle, and look, I've already done it up here. So I'm going to do the same thing down here. But I know that 13 pi over 4, because we graphed it up here, is right here. That is 13 pi over 4. Now, in this one, it started here. This was its initial side. This is its terminal side, but it went around a whole bunch of times. So in this case, it makes it kind of easy to find a positive and negative coterminal because I can go around a whole bunch of times. There's actually an infinite number of coterminal angles because I can just keep going around. Or I'll just go around one time and find the positive one. So if I go from here this way, well, how far around is that? Well, remember our measurements up here. This was 4 pi over 4. This is 2 pi over 4. This is 6 pi over 4. Scooch down a little bit. So we went 2, 4, 6, 8, 10, 12. And then between 12 and 14, well, that's halfway. So that's only one more pi this way. So 4 pi over 4 plus 1 pi is going to give me 5 pi over 4. is our positive coterminal angle. Now we need a negative coterminal angle. So now I'm going to go this way. So I can go, this is now negative, this is the same as negative 2 pi over 4 as I go around this way. And then I get to negative 4 pi over 4. So halfway between those two would be negative 3 pi over 4. So my negative 1 is negative 3 pi over 4. Okay, I did kind of the harder one with the radians, so I would suggest that you pause and try to do this easier one with the degrees. So above, we had already graphed this angle. I'm going to do it in pink here, and it was right here, right? And we only went around once. So from here to there is negative 210. So if I want a positive one, I just need to go from here to there, right? From there to there would be a positive coterminal angle, and I just need to go ahead and take 360 and subtract 210, so I'm subtracting the pink angle here, and I get 150. So my positive coterminal angle is 150. Okay, so now with my negative one, well, I can't just go right from here to here because that one's already the original angle. So I'm going to have to go past it and back around again. And I can go as many times as I want. I can come up with an infinite number of angles, but I just need one. So I'm going to go past it once. So let's start over here. 210, pass it all the way around and back at it. That means I'm adding another 360 degrees on it in the negative direction. So I'm at negative 210 and I'm subtracting 360. Which means I come up with negative 570 degrees is my negative angle. Okay, now we're going to find some trig ratios when given angles. So on this drawing here, let theta be any angle in standard position and let point P, x, y, be any point on the terminal side of the angle. So here I will draw an angle in standard position, like that. And so I have this point on the terminal side called P, and it has the coordinates of x and y. So what that means then is this is x units over, and this here is y units up. And then we're just going to call this long part the radius. Okay, and just remember, by the Pythagorean theorem, you could find the radius because that's just the square root of x squared plus y squared. All right, so what are these trig ratios then? So looking at this, this is theta. We're going to draw this really small in there, theta. Sine of theta is opposite over hypotenuse, so we have y over r. So cosine is adjacent over hypotenuse, so x over r. And I bet you can fill in the rest of this, so you can come up with the rest of these. Okay, so these here are just the reciprocals of these. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So check your answers here. So for the unit circle, we're just going to use this information right here, down here, but I'm also going to bring up that for the unit circle, because this is going to come up later on in the next video, when the radius is just 1, we have the following. Well, if I have sine, and sine is y over 1, well, that y divided by 1 is just y. Right? So sine of an angle is just the y of that point. It's just the y of that point. And cosine of an angle then is x divided by 1, because adjacent over hypotenuse, the radius being 1. Well, the cosine of an angle is just the x of that point. And then lastly, since tangent is y over x, it's the same as sine of theta over cosine of theta. So these things are kind of interchangeable here, and we'll use that information. All right, so In this case, we're not talking about the unit circle. Okay, and I'll show you why. So find the 6 trigonometric ratios of theta whose terminal side passes through the given point. All right, so let's plot this point. We have 1, 2, 3, and we have 1, 2, 3, 4. All right, so here's our angle. The terminal side passes through that point right there, which is 3, 4. And I'm going to write the 6 trigonometric ratios. That means I need the different sides of a right triangle. So when I drop this down here, I now have a right triangle. So this side is 4, because we went up 4, and this side is 3. And then how are we going to find this last side here? Well, we're going to have to use the Pythagorean theorem. And we have 3 squared plus 4 squared, and hopefully you're familiar with this one, but this is a Pythagorean triplet, and you end up with 5. Okay, so in this case, this is not an angle on the unit circle, right? Because our radius is not 1, it's 5. Okay, so that means since the radius isn't 1, we can't just say that sine is y and cosine is x. We're actually going to have to figure them out by doing SOHCAHTOA. So we're looking for the 6 trig ratios. So go ahead and set yourself up with those. Okay, so make sure you have yours. So now sine is opposite over hypotenuse, so 4 over 5. Then cosine is adjacent over hypotenuse, and so on. You should be pretty good at this. And then when you get down here, you're just going to have the reciprocals of this above. All right, so now let's try this one. Now we're at 3, 1, 2, 3, negative 4. 1, 2, 3, 4. So 3, negative 4 is this point right here. And then if we draw this as a triangle, that means this side is 3, this side is 4. But instead of just being 4, it's now negative 4. So negative 4, but when we go to find this last side, it's still going to be a positive. So our radius is always a positive. That's positive 5 there. All right, so what does that do for our trig ratios? Well, not a whole lot. They're still going to be, it's still the same triangle. The only thing that's going to change is the sign, so only signs change. So I'm going to copy and paste this over here. And now I'm going to look, well, where does the sign change? If the sign changes, everywhere there's a 4. So this is now negative. This is still positive. This is negative. This is negative. This is still positive. And this is negative. So you can see that sine and its reciprocal both became negative. Cosine and its reciprocal stayed positive. And tangent and its reciprocal both became negative. So as long as you have the same triangle, the ratios are going to stay the same. The only thing that's going to change are your signs here. And we're going to see that when we get into the unit circle and the radius is always 1, we're always going to have the same numbers for our ratios, but our signs are going to change depending on what quadrant we're in. All right, so doing this is going to lead us into the signs of trig ratios down below. We'll see how we can predict this without actually doing a problem or without actually having an angle. All right, we can determine the sign of a trig ratio if we know the quadrant. So if we were to have an angle in this quadrant, and we have this point, well, we've already done this, so we have point xy. Well, both of them are positive. So what that means is if you look up here, since sine is just the y value over the radius, and both of them are positive, the sign is always going to be positive. Cosine is just the x value over the positive radius. So if the x value is positive, then of course cosine and its reciprocal will be positive. Same for tangent. We have positive over positive is going to give us positive. Same for the reciprocal. So in this first quadrant here, we have all positive. Okay, so what about if we have a point in the second quadrant? Well, now our x value is negative. Negative whatever the value is. It's going to be a negative x, and the y value is going to be positive. So if we look up here again, everywhere there's an x, so right here for cosine, I have a negative x divided by a positive radius. Well, this is going to be, cosine is going to be negative, so is its reciprocal. Same for tangent. I have an x, but I have a positive y being divided by a negative x. It's going to be negative, so will its reciprocal. So in this case, only sine is positive. So for this quadrant here, sine is positive. Okay, let's find a point in here. We still have a negative x, but now we also have a negative y value. So now our y, our negative y divided by a positive radius is negative. Our cosine, well, we have a negative x divided by a positive radius is negative, but our tangent, now we have a negative divided by a negative. So that is going to be positive. Okay, so last quadrant here. Our x comes back to positive, and our y is negative. Oh, we didn't write this in, so our tangent is the only one that's positive here. Okay, you can prove it to yourself by looking above, but in this case, the only thing that's going to be positive is our cosine. So if you look at the first letter here, you can remember this acronym to help you figure out what the sign is depending on the quadrant. So we have A, S, T, C. One way I've heard to remember this is all students take classes. If you can come up with another one, let me know. All right, so let's apply this in some examples here. We just need to figure out what quadrant these are in to determine the sign. So cosine 143. So what quadrant is that in? Well, if this is 180 and this is 90, I know that it has to be in this quadrant right here. And all I care about is the quadrant. You can draw an angle, or you could just say, oh, it's in this quadrant. And then all students, well, only sine is positive in this quadrant, so cosine of an angle in this quadrant must be negative. Okay, how about this one? Again, you can change this to degrees or do fractional parts here. So 5 pi over 5, right? And we're going negative, so we're starting here. This is negative 5 pi over 5. So if I were to back up here, I have 2.5 pi over 5, which seems like a weird number, but it doesn't really matter because all we care about is what quadrant it's in. So as we go from 0 in the negative direction, we're going to be in this quadrant right here. And secant, well, secant is just the reciprocal of cosine. And since cosine is negative in this quadrant, the answer to this one is going to be negative. All right, now for this one, we're given an interval. So we got to figure out where this interval is. Well, I know pi over 2. This isn't a point. Remember, this is interval notation, except our numbers here are in radians. So pi over 2 is right here. And it's going to 3 pi over 4. Well, so I can work with the same denominator here. This is 4 pi over 4. So 3 pi over 4 must be before it someplace. So I'm going to say it's right in here someplace. So cosecant is the reciprocal of sine, and in this quadrant, sine is positive. Okay, last one for you. We are looking for 3 pi over 2 to 2 pi. Well, here's 2 pi. Here is 3 pi over 2. So from this to there, this quadrant, or on this interval, we are looking for tangent. Tangent is negative in this quadrant, since the only one that's positive is cosine. All right, thanks for watching, and I will see you in class.